Let's try a problem. So this is an actual problem off the 2016 exam. Back then they had 5 choices, now you only have 4 choices. Yeah, better for you. Oh, is that enough? Thank you. Yep.
That's the question of the day.
Well, kind of. The MathPo website hasn't started posting new problems yet. They were supposed to start yesterday and they didn't. So just give this problem a shot. I'll give you 2 minutes from right now and we'll see if we can come up with it. One more minute. All right, who thinks they know the correct answer? No. Raise your hand if you think it's C. All right, who thinks it's something else? Well, C. Raise your hand if you think it's B. Seems like a lot of people. So who could tell me why they think it's B?
MBT.
MBT. Okay, so MBT, remember the picture for mean value theorem is if you have a function that goes like this, then, and this is A, and this is B, then there has to be a point, as long as it's differentiable, there has to be a point between A and B where the derivative is equal to that slope, right? So let's see if that works here. If you take this interval that they give us and find f of 5 minus f of -1 over 5 minus -1, this ends up being 18 plus 30 over 6, which is 8. So yes, by the mean value theorem, B is the one that has to be true. Let's look at why the other ones aren't necessarily true. If we plot these points, for example, like let's just make a little scatter plot of points. -1, -30 is like over here somewhere. 0, -2 is like here somewhere. This is not on the scale, but 0, -2 is there. 310 would be like here, and 518 would be here. Okay, so just because it appears as if it's increasing doesn't mean that it is the whole way. Like, right? You could have a function that dips down and then goes back up, right? This is just selected values. It could do this the whole way. It could just be like doing like crazy stuff in between those points, right? So we don't necessarily know that it has no critical points. We don't necessarily know that the derivative is positive everywhere. Look at my green picture. We don't necessarily know that it's concave down the whole way. This one isn't, right? And this one also has points of inflection. So this is like a counterexample for all the other choices. Does everybody understand that? But this one still fits with the mean value theorem. In this case, there would be lots of points that have that slope, right? Like there would be, this point has that slope, and this point over here has that slope, and this point has that slope, and this point has this slope way down here. So in this case, there's just lots of C values. All we know is that there has to be one though. Any questions on that? All right, so I'm gonna try and do a problem of the day like this every day, unless I forget. So once MathBoat comes up, it'll be less thinking for me. I can just go to that website and we can just look at it. But until then, I'll just try and come up with a problem and like an old actual problem and see if we can come up with it. Okay. So today, well, first, yesterday we talked about different properties of definite integrals. Any questions on that stuff? Pretty straightforward, but. Okay, so today we're going to talk about definite integrals of piecewise functions. Okay, like for example, suppose you have something like the integral, well, so let's define a function piecewise, like f of x equals, let's say it's two pieces. It's x squared or x less than or equal to 0. And suppose it's x cubed minus 1 for x greater than 0. There's this piecewise defined function. All right? And suppose they said find the integral from -2 to 1 of f of x dx. Well, if this is an interval of x values from -2 to 1, the function actually changes partway through that interval. So what you have to do in a piecewise function like this is you just have to have two different integrals. One for the first part of the function that's defined to be x squared, and one for the second part of the function that's defined to be x cubed. That's it. That's the whole point of this stuff. So you're gonna like just examine the intervals over here to see where it changes. In this case, it changes at 0. And then you're just gonna write two integrals that change at 0. You're gonna integrate from -2 to 0 the part of the function that's equal to f of x on that interval. So in that case, it's going to be x squared plus the integral from 0 to 1 of the part of the function that's equal to that, equal to f of x on that interval. It would be x cubed minus 1. Does that make sense? That's the whole trick. That's all there is to this stuff. And then you just evaluate them separately. So this one would be x cubed over 3 from -2 to 0, plus this would be x to the 4th over 4 minus x from 0 to 1. So if you substitute numbers in, you get 0 minus -8/3 plus, put 1 in, you get 1/4 minus 1 minus 0. Always be careful of signs and sign errors. If this was a non-calculator question, if it was a calculator question, I would just use my calculator probably, but maybe not. This one's kind of on the border about in terms of if it would be more work to use your calculator, but in a lot of cases, I just use a calculator. But if it's non-calculator, you got to be careful about signs. This is just going to be 8/3 plus 1/4 minus 1 is actually -3/4. So 8/3 minus 3/4. And then you'd have to get common denominator and whatever. Okay? In fact, if this was free response, I would actually just leave it just like that. That would be full credit. Okay? Let's do another example. How about something like f of x equals 2x if x is less than or equal to 1, and 3x squared minus 1 if x is greater than 1. Okay, we want to find the integral from 0 to 2. So the integral from 0 to 2 of x. So the place where this function changes is at 1. So we're going to integrate from 0 to 1. What's the function that's going to be in that integrand? Yeah, 2x. It's the function that is defined to be f of x on that interval, 2x, x, plus the integral from 1 to 2 of the other function, 3x squared minus 1. And then you get the idea from there. Any questions? Anyone want me to actually do it from there, or you're good? Okay, so then the next thing that we need to worry about then is absolute value. Sometimes you have absolute value functions as an integrand. Absolute value. As an integrand. So the thing to remember about this is that absolute value functions are really piecewise functions, but they're kind of disguised. So remember the definition of absolute value. Remember, the absolute value of x is really defined to be a piecewise function. It's x itself if x is greater than or equal to 0, and it's x with a sign change if x is negative, right? That's what this is saying. It's saying if the stuff in the absolute value happens to be positive, you keep it the same. If the stuff in the absolute value happens to be negative, you change its sign. That's what this is saying, right? So if you have more complicated stuff inside the absolute value, like for example, what if you had something like the absolute value of 2x minus 6. 2x minus 6. Well, this is just going to be either 2x minus 6 if 2x minus 6 is greater than or equal to 0. And it's going to be the negative of that if 2x minus 6 is less than 0. And then you can take these linear inequalities here and just solve for x to make it a little simpler. Like this linear inequality right here, you could write it as 2x is greater than or equal to 3, x is, or 6 rather, and then x is greater than or equal to 3. And this inequality really can be written as 2x is less than 6 and x is less than 3. So if I'm asked to find, for example, the integral from 2 to 5 of the absolute value of 2x minus 6, x, I would have to do this analysis right here, writing that absolute value as a piecewise function, and then do the same thing we just did with the other piecewise functions. So this function changes at 3, so I'm going to have to integrate from 2 to 3. Which function is it going to be for the integrand here? First one or the second one? Second one, definitely, because x is less than 3 in that whole interval, right? So I'm just going to simplify this by distributing. This is actually negative 2x plus 6. That'll just make the integration a little easier. Dx plus the integral from 3 to 5 of the top function, 2x minus 6 dx. And then, again, the evaluation part's pretty easy. The hard part's just rewriting it so that it's in the two different integrals. Any questions about that? Okay, I thought maybe a good use of time now would be just to look at the homework assignment. The assignment's been posted on Google Classroom. They didn't have a good assignment on it in Delta Math, so it's on Google Classroom. Let's just look at that handout and just do a couple of the harder ones on there, because there are a couple that are different. Okay, so let's look at that. I have it here. I can put it up on the board. Just a second. Okay. So the first ones are fairly straightforward. They just give you a piecewise function. You have to figure out where it changes and then do the two separate integrals. And by the way, if you want to use your calculator for this homework assignment, that's perfectly fine. The point of the assignment is not evaluating integrals. The point of the assignment is like figuring out what integrals to evaluate based on the piecewise function. So that's kind of, you can save time by using your calculator. All right, so let's do a couple of these absolute value ones because I think they get a little weird. If you look at these first two, number 8 and 9, they're just linear expressions inside the absolute value. So they work very similarly to the one we just did. The rest of them are higher order polynomials inside the absolute value. So let's do a couple of those just so you get the hang of it, okay? Let's look at this one, the integral from 0 to 3 of 2x squared minus 8 in the absolute value, okay? So let's look at that. We have the integral from 0 to 3 of the absolute value of 2x squared minus 8. So the first thing you should do in this problem is just take the absolute value stuff and rewrite it as a piecewise function. And you always do it the same way. The absolute value of 2x squared minus 8 is either going to be 2x squared minus 8 or negative 2x squared plus 8. It's either the expression itself or the negative of the expression. It's the expression itself if that expression is greater than or equal to 0. It's the negative of it if that expression is less than 0. Your next task is to figure out what this actually is in terms of simpler intervals, right? Simpler intervals of numbers, like solve this for x, in other words, right? So you have to remember back to Algebra 2 probably, or maybe we did it last year, I can't remember, to solve a quadratic inequality like this, right? So I'll remind you the way I teach it, but Mr. Kelly might do it a little bit differently. I'm not quite sure. But here's the way I do it. If I'm trying to solve this inequality, 2x squared minus 8 greater than or equal to 0, the first thing I do is I pretend like it's an equal sign and I find the roots of the quadratic. So if this was an equal sign, I would factor. So this factors as 2 times x minus 2 times x plus 2. So the roots are 2 and negative 2. I pretend like it's an equal sign. Then I draw a little sketch of the parabola. I know this is a parabola that opens upward because it has a leading coefficient that's positive. So what this graph right here, if this is y equals 2x squared minus 8, it looks like a parabola opening upward, crossing the x-axis at negative 2 and positive 2. That's what this picture looks like. Then I analyze the inequality. This is supposed to be greater than or equal to 0. Greater than 0 means above the x-axis. Less than 0 means below the x-axis. And equal to 0 means on the x-axis. So this corresponds to points that are on or above the x-axis. So this interval right here, 2x squared minus 8 is greater than or equal to 0, really corresponds to x is less than or equal to negative 2, or x is greater than or equal to 2. This interval right here, 2x squared minus 8 is less than 0, that really corresponds to numbers that are between negative 2 and 2. Is that ringing a bell? Is that how Mr. Kelly does it? I'm not quite sure. Or you don't remember? Does it seem logical? Everybody understand what I did? Okay. So now I can answer the question. This actual integral that we're trying to solve, the function changes at negative 2 and 2, right? Well, negative 2 doesn't come into play in the interval that we're interested in, so I can ignore that. What does come into play is positive 2. So I got to integrate from 0 to 2 something plus the integral from 2 to 3 of something else. Which function is it between 0 and 2? The bottom one. Negative 2x squared plus 8. And between 2 and 3, it's this function. So this is going to be 2x squared minus 8. And then that's it. Whatever your calculator says, that's the answer. Okay. What I don't want you to do is don't use the absolute value function on your calculator and just type it in. That would be a waste of your time because you have to be able to do this. It'll be a non-calculator question on the actual AP test. Okay. So don't do that. You're hurting yourself if you do that. Okay. Let's just try one more. Let's try the one, I think it was a cubic or something. Let's see if we can figure that one out. Let's try one of these last two. The last one seems harder, maybe. I don't know. What do you guys think? 12 or 13? Which one do you want to do? 13. Okay. So can somebody write it down and then read it to me? Because I'm not going to remember what it says. So the integral from 0 to 4, absolute value of x cubed minus 5x squared plus 6x. All right? Everybody ready?
I got it.
Okay, thank you. So the integral from 0 to 4, and then what was the integrand?
X cubed minus 5x squared plus 6x.
Thanks. All right, so let's do this analysis. So you would say absolute value of x cubed minus 5x squared plus 6x is either x cubed minus 5x squared plus 6x, or it's negative x cubed plus 5x squared minus 6x. It's one of those two things. It's the top one if x cubed minus 5x squared plus 6x is greater than or equal to 0, and it's the bottom one if x cubed minus 5x squared plus 6x is less than 0. Everybody cool with that? Now let's solve this inequality. So if I have x cubed minus 5x squared plus 6x is greater than or equal to 0, for example. It's the same process. I'm going to pretend like it equals 0 and find the roots. So I would factor this. X times x squared minus 5x plus 6. That factors as x times x plus 1, x minus 6. No, that's not right. Minus 2, minus 3. Minus 2, x minus 3. Right? So the roots are 0, 2, and 3. Now this one's kind of the same as last one, but it's a little bit different because it's not a parabola. It's a cubic. Remember, cubic functions generally are shaped like this, right? So if there's 3 roots, then that means that the x-axis actually runs through the middle of it like that, right? So if the roots are 0, 2, and 3, it kind of goes like that. There's 0, there's 2, there's 3. That's the picture. Does everyone understand how I'm getting this? So if the question says, when is this graph greater than or equal to 0, that corresponds to above or on the x-axis. It's that piece and that piece, which is really x between 0 and 2, or x greater than or equal to 3. All the endpoints are included, right? Because it's greater than or equal to. It's going to be negative on the other intervals. So it's going to be x less than 0 or x between 2 and 3. That's when it's negative. That's the hard part of these problems, is like figuring out the inequality that for the intervals. So this is just going to be, we're going from 0 to 4. Between 0 and 4, this actually changes a couple times. We're going to need 3 integrals. We're going to have to integrate from 0 to 2 of one function, and then from 2 to 3 of another function, and then from 3 to 4 of the first function again. You see why you need 3? You can't somehow integrate from 0 to 2 and from 3 to 4 all at once. It's impossible. You need to have 2 separate integrals to do that. Then it's just a matter of figuring out which is which, right? It's going to be the top function in the first and the third integral here, and the bottom function in the middle one. Agreed? So this is going to be x cubed plus or minus 5x squared plus 6x dx. The second one's going to be negative x cubed plus 5x squared minus 6x dx. Hard to read. And the last one's going to be x cubed minus 5x squared plus 6x. Do you understand? Okay. So the rest of the handout should be pretty straightforward. That was definitely the hardest problem, I would say. But the first 2 are just linear. This one is a simpler quadratic than the one we did. This is a simpler cubic than the one we did, in my opinion. But remember, since it's a negative, it actually is going to be shaped like this. So just be careful about that. Okay? The rest of them, you just set it up according to whatever they give you. That's it. Any questions? All right, I'm going to stop recording. So the homework is just on Google Classroom. Also, remember,